Hello everyone, welcome back. In this example, we are given our function f, which is now a function of 3 variables instead of 2 like we've seen in some of our previous examples, and we're asked to find the partial derivatives of our function with respect to x, y, and z. And so our function f is defined by the equation sine of the quantity x times y times z plus the quantity x squared times y cubed plus z to the fourth. So let's go ahead and jump right in and start by finding the partial derivative of our function with respect to x. And so the key thing to remember here, and when we're finding any partial derivative, is we always treat the other variables as if they are constants. So if we are differentiating sine of xyz plus x squared y cubed z to the fourth with respect to x, then we're treating all the y's and z's as if they are constant factors. So if we want to differentiate sine of xyz, that first piece, well, it's really like differentiating sine of x times some constant factor. In order to do that, we have to use the chain rule. So how does the chain rule work? We start by taking the derivative of our outer function, which is going to be our sine function. That gives us cosine. Then we evaluate the derivative of the outer function at the inner function, which is going to be xyz. All right, and so we can't forget that last step of the chain rule, which is to multiply by the derivative of our inner function, which is now xyz. When we're multiplying by the derivative of this inner function, we're taking the derivative with respect to x, and so y and z are just like constant factors. So this is like differentiating 3 times x. Well, what's the derivative of 3x? It's just that constant factor of 3. So what's the derivative of xyz with respect to x? It's just that constant factor of y times z. Okay, so the derivative of sine of xyz with respect to x is cosine of xyz times yz, but we still have to add to this the derivative of our second term, the derivative with respect to x of x squared times y cubed times z to the fourth. But if we want to differentiate that term, it really just comes down to differentiating the x squared because y and z and their powers are treated as constants. So the derivative of x squared is 2x. Then we just have to reapply those constant factors, bring them back in. And so we get 2x y cubed times z to the fourth. And so this is our partial derivative of our function f with respect to x. The only thing I might do to rewrite it slightly differently is bring those constant factors of y and z in front of cosine. So maybe we can write this as y times z times cosine of xyz plus 2x y cubed times z to the fourth. All right, but we have 2 more partial derivatives to find for this example. So next, let's go ahead and a little bit quicker find the partial derivative of f with respect to y. So using the chain rule, the derivative of our outer function turns our sine function into a cosine function. We still have to evaluate at the inner function of xyz and multiply that by the derivative of our inner function xyz. But now we're differentiating with respect to y, which will make our y factor disappear and leave us constant factors with respect to y of x and z. We still have to add to this the derivative of that second term, x squared y cubed times z to the fourth. Now we are differentiating with respect to y, so the x squared and the z to the fourth are going to remain the same, and the derivative of that y piece will give us a 3y squared. So we can write this as 3x squared times y squared times z to the fourth. And again, if we wanted to, although I'm not going to write it down, we could bring that factor of x times z in front of our cosine function like we did for the first partial derivative, but that really just makes it look nicer. Doesn't actually change the expression at all. All right, so we have 1 more partial derivative to find to finish this example off, so let's go ahead and get it done. We're now taking the partial derivative of our same function, our same equation, but now with respect to z. So x and y are treated like our constant factors. So a lot of similarities are showing up between these partial derivatives, but that is not always the case. So again, we've got to use the chain rule to get started over here. We're going to get cosine of xyz, just like we have for all the other partial derivatives, but the derivative of the inner function is going to be different, just like it was for the other partial derivatives. Now we are differentiating with respect to z, so it's going to make that z factor disappear or go away, and we're going to be left with the derivative of the inside just giving us a factor of x times y. We still have to add to this the derivative of the second term, but now with respect to z, and so that'll give us a 4z cubed multiplied by x squared times y cubed. So we'll get 4x squared y cubed times z cubed to finish off the partial derivative of our function f with respect to z.